So we're looking at the water molecule, and we just added up our valence electrons for each atom. So now we're going to finish. And what I was saying is we connected everything with a dashed line, and that was 4 electrons that we have used so far. So we came back over here from our total, and we subtracted the 4, and that left us with 4 electrons we still need to place. What you want to remember is that hydrogen follows the duet rule. And what does that mean? How many electrons does he want? Correct, he wants 2. So hydrogen, if you notice, he already has 2. Hydrogen never gets any dots on him because once you put a dash on hydrogen, that is 2 electrons. So the hydrogens are good to go. They're happy. They're stable. They look like helium as far as they're concerned. So hydrogen is satisfied. So now let's look at oxygen. He is not satisfied. Oxygen has to have 8. He's not going to be happy till he has 8. So notice we said we have 4 electrons we still need to place. So we're going to put the dots on the top, 2, 4. Now count what's around oxygen. He has 2, 4, 6, 8 around him. So you are finished. That's what water looks like, a water molecule. Hydrogen has the duet rule. Oxygen has its octet rule satisfied. Both atoms are now stable. The fourth example. Now here we have a polyatomic ion. We learned this is called the cyanide ion, Cn -1. So we're going to add up our electrons just like before. Look at your carbon. He has 4 valence electrons. Nitrogen's right beside it. He has 5 valence electrons. So let's add these up. Carbon has 4 valence electrons, heavy group 4A. Nitrogen has 5. Let's heavy group 5A. Now what you have to be careful of with your polyatomics is this charge here. What does it mean? We are adding up our valence electron job, and that charge, when you have a cation or an anion, you have to take into account what happened with the electron. A -1 charge means that it gained 1 electron. So that means over here when we're totaling them up, we have to add 1 electron. So that gives us a total of 10 electrons that we're going to use for bonding. Now there's really not a central atom here because it's just carbon and nitrogen. Keep in mind the closest distance between 2 points is a straight line. So we're just connecting them with a straight line. There is really no central atom. So that's 2 electrons we've used so far. So come back and subtract. -2, that leaves you with 8 electrons we're still going to place around the atom. Now so far, every structure we've drawn has had just single bonds. I'm going to show you in this example one where you will know that you have to form multiple bonds. You want to always assume it's single bonds unless you have to share. And this is going to be a situation where we're going to have to share electrons in order to satisfy the atoms. All right, so we just said we have 8 electrons to place. So I always start with the atom on the left-hand side, and I do not leave him until he's satisfied. So I'm going to start putting my electrons in pairs around the carbon until he has 8 total. Keep in mind, right now he has 2. All right, so I'm going to put 2, 4, 6. So carbon now has 8 around him. Notice I put 2, 4, 6 of the dots around him. I had 8 dots. I'm going to come over here to my nitrogen and continue placing. There's 8. 2, 4, 6, 8 dots. And that's all I had, y'all. So this is the first time that we've run out of electrons. Everything we've done so far has had the perfect number of electrons. Everything worked out just right. And so we didn't have to do anything special to make it work out. Well, here's what we got to do now, y'all. We got to figure out how to make these electrons share so that each atom has 8. I want to remind you what these dots are called. These dots, these electrons, when they're drawn as dots, are not being shared. These are called lone pairs. Because I think of it this way, they're available to be loaned out. Now, I know that's spelled differently than taking out a loan at the bank. That would be O-O-A-N. But the idea is these can be loaned or shared. Now, if you come back and look at carbon, the reason I finished him first, make sure he had his octet, is because I want to be able to clearly see who is deficient in their electron. Right now, the nitrogen is not so happy. Nitrogen only has 4 electrons around him. 2 here, and then 2 more here. That's 4. He's got to have 8. Nitrogen is very upset right now. Carbon has plenty, so he can loan him some. Kind of like you take a loan out at the bank. He's going to swing them to him. So watch me swing them. Okay? So carbon is going to take 2 and he's going to swing them down. Now when they're shearing them, you do a dashed line. So I swung these 2 here down, made a double bond. Now I'm going to erase the 2 that I swung because they've been placed in the middle now. Notice carbon still has 2, 4, 6, 8. Carbon's still happy. What about nitrogen? How many does he have? Count them. 2, 4, 6. Nitrogen's still not very happy. So let's swing another pair. Take these and swing them up. That means you're going to make another bond here. So these 2 electrons now are being shared. Now, count the nitrogen. 2, 4, 6, 8. Nitrogen's happy. Carbon's happy. Now, just because I want my stuff to be symmetrical, I'm going to move these electrons over here. Keep in mind they can move. I would not count it wrong if you didn't move them there, but I just like mine to be symmetrical. So what we have is a triple bond with lone pairs on each side. Now, the only thing you do different, since it's a polyatomic ion, is you have to put square brackets around it and then put its charge to indicate the charge it has as an ion. So here with cyanide ion, this will be his Lewis structure. Triple bond in between the carbon and nitrogen. It's a very strong bond. Okay, the last example is for carbon dioxide. So let's add up our electrons. Carbon has 4 valence electrons. Oxygen has 6 apiece. So let's go back and look at that one. We're going to do carbon dioxide, our last example today. Okay, carbon dioxide. Carbon, we said, has 4 valence electrons because he's in group 4A. There are 2 oxygens. So I take 2 times his valence electrons. Since he's in group 6A, he has 6 valence electrons. That gives you 4 plus 12, which is 16. So we have 16 total electrons here with carbon dioxide. Carbon is my central atom, so I'm going to place him down first. Carbon, now put 2 oxygens. Now you can put the oxygens, as long as you keep them symmetrical, you could put it on the top and bottom, or left or right. I did left and right. So we've used so far 2, 4 electrons. So come back and subtract. 16 minus 4 means I have 12 dots to place. I got to put the remaining electrons around the structure until everybody has an octet. So I'm going to start by placing the dots around oxygen. I have 12 dots. 2, 4, 6, 8, 10, 12. And I've run out, y'all. Keep up with how many you put out. We put out 12. Check the octet rule. Look at oxygen. Oxygen has 2, 4, 6, 8. Oxygen's happy. Look at the other oxygen. 2, 4, 6, 8. He's happy. Look at carbon. 2, 4. Carbon's not real happy right now, y'all. We're going to have to borrow and share. Notice, again, we have run out of electrons. So we're going to have to borrow and share. Which element has some lone electrons they could share? Lone pairs can be lone. So find elements that are attached to the carbon and swing some to them. So both oxygens have some. So let's take a pair from this oxygen and swing them down. And you're going to create a double bond here. So this is your double bond. One goes down. Now, it really wouldn't be fair to borrow all of them from that same oxygen. Okay? So let's not gang up on him. Let's take another pair from the other oxygen. Remember, y'all, keep it symmetrical. So swing a pair down from the second oxygen. That way, both are sharing, and neither oxygen feels slighted if you have it that way. That gives you 2, 4, 6, 8 around the first oxygen, 2, 4, 6, 8 around the second oxygen, and 2, 4, 6, 8 around your carbon. Everybody's happy, everybody's got their octet, and you are finished. Okay, I hope that makes sense, and we'll practice these some more in class tomorrow. Thanks.